Okay, today's lesson is lesson number 80. This is solving quadratic word problems. So we're going to be looking at kind of real life application problems that can be solved using quadratic equations, which is what has been the topic for the past few lessons, right, for the rest of this unit. So we're going to be applying what we know now about solving quadratic equations. We'll be applying those to word problems. So first thing we're going to want to do, like in any word problem, is read the problem very carefully, and we want to identify what the exact question is. We want to know what it's actually asking us to find. Then we'll identify the variables and any equations that can be used. So if it's talking about a square, do we need the equation for the area of the square? Or if it's talking about a rectangle, do we need to know the equation for the area of that rectangle? And so on, okay? Then we'll replace any values into the variables in the equation. So if it gives us the height, we would plug in the height. And then we'll solve for whatever the missing variable is and make sure that that's answering this initial question, okay? Okay, so for number 1 and 2, these are two very similar problems. So number 1, I showed the class we would start by kind of drawing a diagram to give us an idea of what this looks like. And the area of this square is 256, right? It says, the question says to find the side of a square with an area of 256 meters squared. So find the side is how the problem starts. That's what it wants us to do, right? So we need to find this side length, which in a square, of course, both sides are the same length, or all four sides are the same length. So I'm thinking, well, I know that the area, I could find this by multiplying those two sides together, right? X, like length times width. But here they're the same, so it's just x squared. And it told me that the area was 256, so I can plug that in for A here. I get 256 equals x squared. I'm just going to flip this to rewrite it a little nicer so that my variable is on the left. Okay, and then I just take the square root of both sides. That gives me x equals plus or minus the square root of 256. Square root of 256 is just 16. So I get that as my answer. But I'm thinking back to the problem, does that really answer the question? It asked me to find the side, so I need to make sure this is a side length, which means it can really only be positive, and it needs a unit. So I would say the side is 16 meters, okay? So just the positive case, and I want to make sure I have the units on there. Okay, then number 2, I had the students do on their own. It's a similar problem, so try this one. Pause the video here and then check your work. Okay, so what we do here is make a square. Again, the area is given as 90 meters squared here, and the side length is what we're trying to find, so we use A equals x squared. So we know x squared then equals 90. So that's what's given to us as the area. So I take the square root of both sides. That gives me x equals plus or minus the square root of 90. But I want to try to simplify this, so I'm looking at the square root of 90. I know that's just 9 times 10. 9 is a perfect square, so the 3 comes out, so it's 3 root 10. Okay, so my answer then is x equals plus or minus 3 root 10. And again, since this is real life and it's this actual side of a square, I can't have a negative side length. So I would say that the side length, I would say that the side length is 3 root 10. And again, I'm using the right units here for meters. Okay, so moving on then to number 3. This is a little bit wordier, but not too bad. So it says a city is planning a circular duck pond for a new park. The depth of the pond will be 4 feet, and the volume will be 20,000 feet cubed. Find the radius of the pond to the nearest tenth of a foot. Use the equation v equals pi r squared h. And in words here, this is what that says. Volume equals pi times the radius squared times the height. Okay, so I'm going to start by drawing myself a diagram. This is what the circular duck pond might look like. So it looks like a circle on top, but it has just a straight depth of 4 feet. And then I have this equation, V equals pi r squared h. And I know that r is this distance from the center to the end, okay? Or to the edge of the circle, I should say. And that's what we're trying to find, right? It says find the radius, so that's the question here. I'm also given some numbers, 4 feet here. I'm trying to think of where I can plug that into this equation. And it says the depth of the pond will be 4 feet. Depth is like height, right? But it's going down instead of like height we think of as going up. But that's still 4 feet, okay? So I know to plug in 4 for h. And then it gives us this other number, 20,000 feet cubed. And it says that's the volume. So I know that I can plug that in for V, which is equal to the volume. Okay, so plugging those in, I have 20,000 equals pi r squared times 4. And I want to rewrite this just to be a little neater, so I'll put the 4 pi together with the r squared and flip it so that, my variable's on the left, okay? Now I'm thinking, okay, I want the r squared to be by itself, so I need to get rid of this thing that's being multiplied to it. To get rid of something that's being multiplied, I just divide. So I divide both sides by 4 pi. This one's going to cancel out, and this one can simplify, so I get r squared equals 5,000 over pi. Again, I got that because these cancel, and then this simplifies to 5,000 over pi. Okay, now I have r squared equals a number. To just get r equals the number, I need to get rid of the squared. I get rid of that by taking the square root. Of both sides. This gives me r equals plus or minus the square root of 5,000 over pi. If this was a test and I didn't have a calculator, I would leave my answer like this, but of course I would just want to talk about the positive one, right? Because having a negative radius wouldn't make sense. But since we have our iPads, I had the students calculate what this would be. So on an iPad you would do 5,000 divided by pi and hit equals and then hit the square root button. On a standard scientific calculator you could probably hit square root and then type in the 5,000 and then the divided by and the pi sign, and it would get it all under the square root correctly, so you could do that. Okay, but moving on here, so when you type this in a calculator, you get r is about plus or minus 39.9, and again, of course, we're just looking at the positive one because it wouldn't make sense to have a negative radius. So in a complete sentence, we would say the radius is about 39.9 feet. Okay. Alright, so for number 4, this is a similar problem. We're talking about a museum and a globe now instead of a duck pond, okay? So the museum is planning an exhibit that will contain a large globe. The surface area of the globe will be 315 feet. So a globe kind of looks like this. Okay, the surface area is like the outside portion. So not how much like water could I fit inside it, but more like how much paint would it take to just cover the outside. Okay, going around the globe. So that's surface area. It says the surface area of the globe will be 315 feet squared. Find the radius of the sphere producing this surface area. Use the equation S equals 4 pi r squared. And in words that says surface area is equal to 4 times pi times the radius squared. Okay, so I have this equation. I know I'm trying to find r, and I know that S is equal to 315, so I can plug in 315 for S. I get 315 equals 4 pi r squared. And again, this is r, the r that I'm trying to find. Okay, if you're doing this at home, try to finish the problem on your own and pause the video here. Okay, so the next thing you want to do is divide both sides by 4 pi. These cancel out. That gives me r squared equals 315 over 4 pi. Okay, now to get rid of this square, I want the r totally by itself, so to get rid of the square, I take the square root of both sides. That gives me r equals plus or minus the square root of 315 over 4 pi. But we could plug this in our calculator. Just make sure that you have the 4 and the pi being multiplied together. Or you do 315 divided by 4 first, then divide that by pi, whatever you get. Okay? If you plugged it in correctly, you would get r is about plus or minus 5.00. So in the context of this problem, that means the radius of the globe is about 5, and we want to make sure we use the right units, and so it should be feet here because the surface area was given in feet. Okay. Alright, so that's all that we worked on in class, and then we graded homework and started on tonight's. So give tonight's homework a try, and I will see you guys tomorrow. Thank you.